This is the lesson for Chapter 3, Section 6, and in this section we are going to estimate some square roots. So let's take a look at what the directions say. So this is approximate each irrational number to the nearest hundredth without using a calculator. Now we're going to approximate, so that means not exactly our answer. So when we talk about going to the nearest hundredth, we're going to be off a little bit, but it's going to be close. So we're going to do it without a calculator. But I am going to use the calculator just to check to see if I'm doing it correctly. And so when I've got the square root of 63, what I'm going to do is I'm going to look for the square roots that are in between, the perfect squares that this number is in between. So I'm looking at 49, which is a perfect square, and the square root of 49 is 7. And then I'm going to look at the square root that's a little bit bigger than 63, and that would be 64. And the square root of that would be 8. And so as I look at these numbers, the square roots that are in between 40 and 64 are all going to be in between 7 and 8. So 63 is going to be in between those as well. Now, 63 is really close to 64, so my guess is the number is going to be somewhere around like 7.9 or so. And that's what I'm going to guess. And so the way you do it is you just take that number, like 7.9, I'm guessing that it is, and I go ahead and multiply those two numbers. So it requires some extra work here. And so it's really cumbersome without a calculator, but this kind of gives me at least a general idea about what it's going to be. So when I go ahead and multiply these two numbers, I end up getting 62.41. And that is pretty close to 63, because if I did 8 times 8, that would end up giving me 64. And so I know it's right in between 7.9 and 8. And so I'm going to go ahead and say it's 7.95. So that's what they want us to do when they say round or just estimate or approximate to the nearest hundredth. They want us to have a number in the hundredths place, and this is in between 7.9 and 8, so 7.95 is going to be pretty close to what it is. Now, let's go ahead and just see what it is on a calculator. If I pull one up, I've got 63, and I take the square root, and there's the button right there, and there it is, 7.937. So actually a better approximation would have been 7.94, but I wouldn't have gotten that unless I went ahead and multiplied 7.94 and 7.94 and then 7.93 and 7.93 to see which one it's closer to. So let's take a look at another one. And here we have 18. So again, what I'm doing is I'm looking for the perfect square that 18's between. So I see 16 as a perfect square, and that is 4. And I see 25 as a perfect square, and that is 5. So I know 18's between these. Now I want to look to see which one it's closer to. It's closer to 4 than 5. So what I'm going to end up doing is trying a few numbers. So I'm going to try maybe like 4.1 times 4.1 to see if that's pretty close to 18. So I go ahead and multiply these numbers out, and I got 16.81. Well, I could probably get a little closer, so let's try another one. Let's try 4.2 times 4.2. And when I go ahead and multiply those numbers, I got 17.64. So that's pretty close to 18. So it's going to be right around 4.2. And if I went ahead and did 4.3 times 4.3, I'm getting something a little bit bigger than 18. So 18.49 is what I get. So, and when we're approximating, since we're approximating, you don't have to actually multiply out all the way. If you just get about what the answer is, you see that this is 17.64, this is 18.49. You're one below, one above, so I know it's in between these two numbers. So the number in between 4.2 and 4.3 is going to be 4.25, and that's how we're going to approximate it. So whatever it's in between, we're just going to add that extra 5 in the hundredths place. So again, you can show you how that works by just plugging in those numbers, 18, and then take the square root. There it is, 4.24. So pretty close to what we ended up saying. So let's take a look at another example here. 87, just a little bigger number, and so you just look for the one it is closest to. And 87's pretty close to 81, which is a perfect square, and that's 9. And the square root of 100 is going to end up being 10. Now, 87 is a little closer to 81 than it is to 100, but it's not really close. So I'm going to go ahead and instead of 9.1. I'm going to try maybe like a 9.2 or maybe even 9.3. Let's try 9.3 when we go ahead and multiply it. Because over here, this was just two numbers away, and 4.2 ended up working. So I'm thinking 9.3. Since the numbers are a little bigger, things could be further away. And when I go ahead and multiply those, I get 86.49. That's really close to 87. Well, that means 9.4 times 9.4 is going to be a little bit bigger. And it sure is, because when I go ahead and multiply those, I get 88.36. So I know it's in between these two numbers. The number in between 9.3 and 9.4 is going to be 9.35. And so again, I can show you how that ends up being the case if you just go ahead and plug in those numbers. 87, you take the square root. There it is, 9.3, and it's in between 9.3 and 9.4. A little closer to 9.3 than the 9.4, though. Well, moving on to the next set of directions, it asks us to compare. So we're going to end up having to use that same strategy of estimating. Now, we don't have to round to the nearest hundredth here because it doesn't say to. We just need to see which one's the bigger number. So here we've got the square root of 3. So I'm going to take the square root of 3 and find out what it's close to. So I see that square root of 1 is 1. The square root of 4 is 2. So I know it's in between those two numbers, about 1.5 probably. And so I'm going to add 7 to that, and I get 8.5. Well, doing the same sort of technique on this next one, the perfect square 4 is 2, and 9 is the number that's a perfect square bigger than 7, and that's 3. So I would say that number is pretty close to 2.5, the square root of 7, that is, and I'll go ahead and add 3 to that, and you see how I get 5.5. So we definitely see that 8.5 is bigger, so that's why I draw the inequality sign opening to the bigger number. Well, the next one, here it's negative 3 plus the square root of 15. So we'll take the square root of 15, look for the smaller square root, which is 9, and that makes 3. Square root that's a little bigger would be 16, that makes 4. So we see that this number is going to be pretty close to 3.5. Probably a little bit closer to 4 than that, but that's okay. We're just approximating here. Well, when I add negative 3, I end up just with 0 5/10. And when I go ahead and do the next one, the square root of 6, well, we can see that that's going to be pretty close to in between. We've got 4 and we've got 9, so it's going to be in between 2 and 3. And so we go ahead and see what that number is, and we've got a, actually, this is supposed to be a 15 instead. So let me go ahead and fix that. It wasn't very clear, but let's go ahead and change that real quick. And go ahead and add in, or just put in the square root of 15 minus 3, and that matches the example a little bit better. Handwriting wasn't as clear as it could have been. So 15, we already know that the square root of 15 is going to be about 3.5, and when I take 3 away, you see those are exactly the same answers, 0.5 I get. So those two numbers are equal in this case. Well, looking at the next one, it's 10, square root of 10 minus 5, and 10 minus the square root of 5. So if I look back at this other one, notice how it's the same numbers. The negative 3 is minus signs in front of the 3 over here. It is as well over here. Positive square root of 15, positive square root of 15. So they're the same exact numbers. And that's what we showed over here. So the square root of 10 is in between the square root of 9 and the square root of 16. So it's real close to 9. So it's going to be between 3 and 4. So we'll just say 3.5 for now. And then we take away 5, and that leaves us with a negative 1.5. Well, I go ahead and do this one. I'm going to do 10 minus, but the square root of 5 is going to be in between the square root of 1, which is 1, and the square root of not 1 actually, let's go with 4, which is 2, and the square root of 9, which is 3. So it's going to be in between 2 and 3, and so that would be 2.5. So when I take away 2.5 from 10, it leaves me with 7.5. So I definitely see how 7.5 is bigger than the negative, so we're going to have the inequality sign open to the 10 minus the square root of 5. So the last set of directions asks us to order these numbers. So taking a look at the square root of 20, same sort of thing. We're just going to break this down. I see that 16 is a perfect square, and that makes 4. And the square root of 20, well, 25 is a little bigger than that, and that makes 5. So I know it's in between, so I'm going to just call that 4.5. So right away I see 4 is smaller than 4.5, so I know this one would go in front of this one if I want to order from, let's go with least to greatest. And looking at the next one, we just need to find out the square root of 35. So 35, let's go with 25 being 5, and the square root of 6, or 36 being 6. And so it's going to be really close to 6, probably like 5.9, but we'll just call it 5.5 for now. Divide that by 2, and that leaves me, if 2 goes into 5, we have just 2 times. So I see right away I don't even need to finish this number here. And I see that 2 is definitely going to be the smallest number. So the way I'd write this down is the square root of 35 over 2 is the smallest, then 4 is the next, then the square root of 20 is the biggest. Well, the last one here, we've got this symbol here. This is called pi, just pi. It's a Greek letter in the alphabet, and it represents the ratio of the circumference and diameter, and a good approximation would be 3.14. So I'm going to do 2 times by 3.14, and when I do that, I end up with a 8, a 2, and a 6, decimal point in between those. So now I have the 32, the square root of that. So I'm looking at the perfect squares. It's between, I've got 5 and I've got 6, so it's going to be about 5.5. And then I've got this 3 times by the square root of 3. So the square root of 3 is going to be between 1, the square root of 1, and the square root of 4. So that's between 1 and 2. And so 1.5 looks like about the number the square root of 3 is going to be. So when I go ahead and multiply that, I get 15, and carry a 1, that makes 4.5. So I see that the biggest number is 2 pi. So the smallest one is 3 square roots of 3. So let's go ahead and write that out. 3 square roots of 3 first, then the square root of 32, and last, 2 pi, because it's the largest number. Well, these are the types of problems that you're going to see on tonight's homework. Good luck.